Exponential functions, remember, they're increasing at a constant rate, and we always wrote them out like it was y equals a times b to the x. I know that there's h's and k's and all that stuff thrown in there, but we're not going to worry about the h's and the k's to start with. Let's put a tick mark on that one.
Hey, no, I'm putting it back.
What did he say?
It's like, I never say that because my phone is always charging. I don't know why that's on the board. You never say that. Oh, but yeah, it's covered.
So in this case, what we're going to work on, yes sir. Not right off the bat. It's going to be exponential. We're not going to be worrying about logarithm stuff. It's just going to be all exponential. It's the e ones. We're not going to be doing any logs. We'll do logistics tomorrow.
Like UPS?
Not so much. It's kind of like you can't. If you think about it, a population. Will population always constantly increase, or will it eventually tail itself off? It's going to tail itself off. That's what's going to look at. We'll look at that tomorrow. So what I want to do is I'm going to write out a function that y equals a times b to the x that goes to the ordered pairs 1, 6, and 324.
It's just b, that's to the x?
Yeah, just b to the x. Remember the value of b was just showing you whether it was an exponential growth or exponential decay problem. If the b value was greater than 1, it was growth. If it was a b value between 0 and 1, it was decay. The a value just meant it was a negative or a positive. Was it going up, or was it going down, or was it going the other direction? So that's all that was. In this case here, we're going to be dealing with positive b values. So here's what happens. We have two ordered pairs that both have an x and a y. So what we're going to do is write out two equations in terms of x's and y's, a's and b's. So we have 6 equals a times b to the first power, and 24 is a times b cubed. So it's going to give you two equations, two variables. Think of it in terms of systems, but it's not with adding and subtraction, with multiplying, which means we have to use substitution. So look at the first equation. Right, so what I'm going to say here is a is 6 divided by b.
Oh, neat.
This is solving for a. And in doing that, it's just going to allow me to substitute in the other equation and solve for b.
So we're always going to solve the a.
Yeah, it's the easiest one to go with. Substitute in here. And the reason why that is because sometimes your b value in the first equations can have an exponent of 1, 2. It could have any of the exponents. Same with the other side. But a is just a. There's no exponents. So it's always easier just to get that one by itself. So you substitute in, and you'll notice real quick, it's pretty easy. 24 is 6 divided by b times b cubed, or b cubed.
Yeah.
What do you get? Good. You play the game of war. B cubed divided by b is b squared. So you have the b there. In this case, you have to worry about plus minus. Remember, when you're talking about exponential, your b value was always positive. It was whether it was between 0 and 1 or greater than 1. So your b value is always going to be positive. Yes, ma'am?
So we're not going to have to worry about that for this whole section, or?
Well, remember, when you're dealing with exponential rules, exponential growth and decay were defined by b value greater than 1 is growth. Ah!
Sorry. That was awful. B's greater than 1.
Don't try it.
Wait, we've done this part before, haven't we?
It was on the back.
Yes, boy.
That's all it was. It was never negative. B was never negative. All right. You don't have to worry about it being growth versus decay because it's still an exponential function. When we do the actual modeling with the calculator, it'll calculate for you.
So we don't have to just have to be confident.
What'd you say?
All right. So what's our answer?
So, like I said, your b value is always positive, so it's 2.
2 and 3.
No, I didn't. So B is 2. What's A?
3. Trace.
So then your final answer would be y equals 3 times 2 to the x. And no, you cannot combine them because 2 to the x is the b value. Correct.
Oh, and then you put
And you're done.
Oh,
And that's what you do. Woo! These are very simple to write out the actual equation given the 2 points. So let's see, you do that one, and then we'll go on to the word problem, where you actually have to do a little bit of work.
What? 36 equals C squared.
I got pi
Oh,
squared.
what? I got
times 12 x.
No.
No.
That's a 2, not a 3, Allie.
Oh, it's a 2. Oh my god. Ellie,
I took a total of 6 naps this weekend, and one of them was 3.5 hours.
So you get 12 for B,
Yes!
then 1/4 for A.
Yes!
There's no C here.
I got 7.
Y equals 1/4 times 12 to the x. And you're done.
This is simple, I like it.
Okay? Yes, ma'am.
Doesn't matter what you're putting, you put a side.
No, it doesn't, but it's usually going to be easier with the first one. A lot of times.
Tries not to say those things.
He's probably like looking back there and really carrots. Yeah. Now he's self-conscious about how many carrots he eats.
Yeah, I'm self-conscious about my carrot intake.
You're
Sure.
a dick.
What's that?
Does the other?
Yes, I'm highly addicted to the carrots because the deliciousness.
You're turning pink like a flamingo. That's why they're pink, you know?
Because they eat carrots?
Because they have something with carrot. They eat salmon.
Yes.
No, it's actually yes.
Okay. Does the other classes look back there and are just like, what the heck?
Well, they put the.
They get annoying, so we're
They
just
put
going to
the,
erase
they
all of
put the
it.
6
Actually, I expected you to erase that on like Thursday.
It's just
I was surprised it was still.
I just get around to it.
Here's the job.
Here's the trick. So what happens now is that I want to take a table of information and I want to show that it is exponential. Now, the way we do this is that we can sit there and plot it in our L1, L2s like we have been. But in order to prove that it's exponential, you have to do something. Because remember, a lot of times that you could set up a curve, and depending upon the data set that you're given, you could be given half a curve. It might be quadratic, you just don't see the other half of it. It might change direction someplace along the line. Now, if it's exponential, there's a little bit of a trick that happens. So let's do this. Let's do an L1, L2 out of this information. I know.
Second memory. Second memory board.
I know, but I only have to do this.
No, you just have to go up and delete the tab. Just put the cursor over the L.
No, it would delete the whole. No,
Just make sure I have all 10 of them in there.
Oh, never mind.
Yesterday there was this car laid downstairs.
Did you guys see? Any of you guys go by University Village the other day? Because there's like 20. No, I was coming back from softball and there's 20 cop cars out there. So like maybe they're
What
one
time was it?
Things happen.
No, guys were getting hauled away in handcuffs. It was yeah,
hauled
maybe-
away.
Maybe they ripped the tag off. That's the worst.
That was well done. That was very well done. Maybe they ripped the tag off the pillow. Let's see, 1.6.
2.7.
You scared Hannah by how hard you were laughing. She like jumped back.
I'm sorry, Hannah, I didn't mean to frighten you.
Now Tango, ready?
What was that?
I'm not scared. I have no. Tango. I have no.
No Tango de Niro?
How do you say I feel like?
Oh, I feel ganas.
Tango ganas de suerte.
I feel.
Like death? Okay.
Literally a vocab.
So does everybody get all 10 of those things in?
Yeah.
All right. Now, think about what's happening with your graphs. When you go to turn on the stat plot to look at it, you're going to want to adjust your window.
Yeah.
Adjust your window first. What are you going to set your x minimum at?
0.
And what's your maximum? 10. What about the y values?
50.
0 to 50, good. So let's go to our window. 0 to 10, and then 0 to 50.
Wait, how do you do that? I know this weird equations.
I want to make sure I'm at hit second stat plot. Make sure that's turned on. I'm going to change that to L2.
Actually, I'm probably it
All right. Does everybody have something that looks kind of like that?
It's not connected.
Okay, that's fine. You can actually make it connected, and if you go back to your stat plot, if you guys want to look at hit second stat plot, see how mine's got connected lines? If you go to where it says plot on, hit enter, the type, if you pick the second one over, it'll do a connect, it'll connect the dots.
Second.
Okay?
Oh, I got that.
It's during my kindergarten. Second light.
Yes.
Oh,
Okay. So now we have our graph that looks like this, and I'm just going to kind of put it on the smartboard for right now. Now, here's the trick in order to prove that you have a linear exponential function. In order to make this work, we could sit there and try to find finite differences and find out that nothing's going to work because it's not a squared term. Yes, sir.
you want us to really start what you want us to calculate?
You can just kind of roughly sketch it. It's not that big of a thing because I'm not going to take the calculator. Okay. You have to have a calculator. Because what I want to do is I want to create a third list here, and I want to take the natural log of your second list.
What?
Because what happens is if you plot in order to show, oops, let me move this down, to show exponential, the graph of x versus natural log of y should be linear-ish. Okay. So here's how you do this in your calculator. I want to go create a third list. Okay? An L3, if you will. We do that again by going to your stat edit. And you see where it says L3? Just go over there. And now what I want you to do is just type in natural log 1.6.
It's the button beneath log.
Button beneath log. And hit enter. And it's going to calculate and put the natural log of, you're going to do all the natural logs of what's in L2.
I thought it was typing stuff.
Nope. Natural log, what's the next one? 2.7?
Yeah.
Natural log 4.4. I have to help. You gotta wait a second. Look at your window. La ventana es not correcto.
The window is not.
Two es correcto.
No, what was he playing?
Oh my.
What?
What, Ellie?
I understand Spanish.
We were literally saying like 3 words.
The window is not correct. Love and fun.
So right now, what I want to do is I'm going to change what we have to graph. Go to your stat plot, second y equals, hit your stat plot, but right now, your lists are between L1 and L2. I want to change it to L1, L3. This is how you do that. Scroll down.
Wait, you want 1 and 3?
I want L3. I want to graph x versus the natural log of y, what we just put in that next column there. To change that, all you have to do is, if you look at your the blue buttons by the numbers, the alphanumeric ones, I think if it's second option 3, button 3, it'll change it to L3 then. Everybody see that?
Yes.
Neato. Second grade.
Second 3. Okay. Now, if I go to my graph, I probably don't see anything, or it's very small because my window's all messed up again.
Just the window.
We're going to adjust the window. What is the x, or excuse me, our x minimum and x maximum should be the same, but let's change our y maximum. What's our y maximum?
Just have 3.
3 after 4.
4. Change it to 4.
Wow.
Isn't that linear-ish?
This is some crazy stuff going on.
So it's linear-ish.
It's crazy.
This is how you prove that you have exponential, by showing that the graph here is linear-ish. Yes, sir?
You say like linear-ish, but we definitely know if it was or wasn't.
Yeah,
There'd
yeah.
be like a drastic change.
Yes, sir. Now, I did this third hour, and I screwed up on one of my y values, my natural log points. I forgot to hit natural log. I just typed in 38.9, and it went nice and straight, and all of a sudden it spiked.
Oh, okay.
And then you were like, that didn't look right, because it was just such a singular anomaly. Just go back and double check your list. It's very easy to type it in incorrectly. So that tells me that this is linear-ish. So now, in order to get my equation, what do we press? Stat, calculate. What are we working with?
Linear. Exponent regular, right?
Exponential, yeah.
Yes, Sarah.
Numero cero.
I'm just digging the Spanish.
Now, yours should automatically default to L1, L2. Did you not get that?
I totally missed it.
Hit stat, hit stat,
Oh, mine didn't even.
calculate, and then just scroll to where you see, if you hit up, you'll find it quicker. To X, reg, EXP, REG.
Okay, 0. Mine didn't even show me.
My first car was a black EXP, Ford Escort, 1989. Somebody around here has one. Someone has a red EXP out in the parking lot. I've seen it a couple times. It was an awesome car.
That's mine.
All right, so then you hit enter.
Did you change it? Mine didn't like even show.
No, because it's going to go, because you want it to be back in L2, because your original values was what you started with. Otherwise, if you did that, it would be graph, and you try to give you an equation of an exponential that's linear.
Mine didn't even like give us that option.
That's fine, you don't have the new operating system, that's all.
Wait, so we have the old one?
Yeah.
Wait, why didn't I get that?
It'll automatically default to L1, L2, so you should have these as your options, right? Your A and B,
Yeah.
then it automatically defaults
So
to,
we want it to be L1, L2.
yes.
Yeah, that's our extra.
Yeah, so basically what you're doing here is you're just doing a couple extra keystrokes just to check to see if it's going to be actually exponential prior to figuring out if it is exponential. What's nice about this is that when you guys do get, when this is parkified, if you will,
Parka.
because they'll ask you to look at the set of data and try to figure out the model of it. Remember how we did it to tell whether or not it was or if it was quadratic or cubic. We did those finite differences, which you guys found to be really, really easy. Well, if it doesn't fall into one of those, you can go into the exponential model. And by checking to see if it's exponential, you just take the natural log of your y values to see if it's somewhat linear. And that's how you check these things. This is a model. It's how you choose models to fit the data. That's all this is, guys. It's really quite basic, if you will. There was power function stuff. There's really no, I don't think we need to really worry about power functions, to tell you the truth. I do like looking at the logistics stuff which we'll do tomorrow, they're just kind of weird because if you think about population, if you have an exponentially growth of population, you're eventually going to run out of space. So population would eventually table itself out. Or die out, yeah. It's like deer population. Yes, sir.
We did something like that biology.
Yeah, bacteria, right?
Exactly.
Yeah, it's the exact same thing. Where it's bacteria growth you can only go for so long before it dies. It increases at an increased rate and then it decreases itself out. So it's like a sideways tangent function.
Hey, Christian, is that what he's doing?
Okay.
Did you guys what do you like?
Do you want to see another equation like that where you try to tell if it's going to be one of those?
No.
We all right?
I think we're good.
I just have
My teacher's just long-term, so.
Will it be like,
When you're doing this, when you're putting it in your calculator, this is pretty, it doesn't look perfect, but it's close enough. So it's fitting the idea.
so wait, would that be like nonlinear? The other one?
This one?
Yeah, like, I know that's like the list 2, but if that were to be, if list 3 were to look like that, would that be considered nonlinear?
If list 3 looked like this also,
Yeah.
then this would probably not be exponential. It could be something different.
So you can just say you can express it.
Well, it doesn't fit the exponential model.
So do you just write that? Just
Yeah.
model?
Okay. But it should be close enough. All right? I mean, I guess we can do another one, but then, let's do this.
I want to remember the math, because I feel like now we get it.
Pavlina.
513.
You probably can't count it.
Yeah.
No, I don't know what 500 is.
Wait, Ellie, you guys are counting it?
No, we got to 200. And you were Jenny.
I'm such a good
You're
teacher
like
today.
Hey, Julie, just
Peanut butter and jelly, 2 bars of tea.
All the
It's the best PB and J.
All right.
I can't like, you're like, but,